1.4, working with radicals. Okay, so we're going to go over a couple definitions first. First, an irrational number is a number that cannot be expressed as an integer over an integer. A b, of course, can't be 0 anyways. Okay, examples of these are pi or e. These numbers go on forever. A radicand is the number actually under like the radical sign, so radical being like the root sign. So in root 7, we have the 7 as the actual radicand. Okay, the entire radical is in the form root of n. So in this case, root 45. This entire thing would be the entire radical. Now we can also have a mixed radical where there's a number in front, say for example, in this case, 3 is in front, and then we have a radical, so like root 5. Okay, again, under the root sign, this number has to be greater than 0. Okay, we can't root a negative number. And then if it's going to be a mixed radical, obviously this number has to exist, this 3. So it cannot be 1. Okay, so operations with radicals. So first we're going to cover multiplication. This is the easiest one. When multiplying radicals, all we do is multiply the radicands, so like the numbers underneath the root signs, and then simplify, if we can. Okay, and I'm going to come back to this note. So for example, multiply the following radicals. Root 5 times root 2 is just root 10. Because essentially what this is 5 times 2. Okay, this one, root 6 times root 7 times root 3. We would be multiplying 6 times 7 times 3. And we get root 126. Okay, and in this case, this is where this note comes into play. So when we multiply two radicals by themselves, so for example, 10 times 10, we get root of 100. But we can actually root the 100 because that makes it a perfect square. Okay, so root of 100, we get 10. So when we multiply a radical by itself, we just get the radicand as the answer. Okay, another way to think of this is root 2 times root 2. Well, a root is actually to the power of 1/2. So root 2 times root 2, so 2 to the 1/2 times 2 to the 1/2. What we're actually doing is we're actually just adding these two exponents. So it's just 2 to the 1. Okay, so moving forward, simplifying radicals. So we simplify radicals by converting them into a mixed radical. Okay, so when simplifying radicals, we look for factors of the radicand that are perfect squares. So when we talk about perfect squares, we talk about 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 8 squared, 64, 9 squared, 10 squared, and so on. Okay, so we look to actually break down the radicand into two terms, like something times something. Okay, we calculate the root of the perfect square and then we write it as a mixed radical. Okay, so for example, express each radical as a mixed radical in simplest form. So 50. Does 50 break down into any of these numbers here? Yes, it breaks down into 25 times 2. So I always put what can be the perfect square in front and then times 2. So here's the thing. What's root 25? 5. Root 2 can't be rooted, so we just rewrite it. So root 50 can also be written as 5 root 2. Okay, 20, looking at these, we can write it as root 4 root 5. Okay, what's root 4? 2, and then we have root 5. Okay, what about 200? We can go root 100 times root 2, and root 100 is just 10. So we get 10 root 2, and that's how we can rewrite them. Okay, multiplication of mixed radicals. So when multiplying mixed radicals, we multiply the whole number by the whole number. We multiply the radicand by the radicand. And then we simplify our answer if possible. Okay, so for example, m root a times n root b, we would be multiplying m and n, and then a and b. M and n, and then root ab. Okay, and division is very similar. When we take the root of a fraction, the radical sign can be applied to both the numerator and the denominator. Okay, so the root or the radical of a fraction, root a over root b. And then in order to fully simplify, what we can do is we can simplify the radical part by pulling out the perfect squares and canceling out, simplifying if possible, and then we look for common factors under the root sign. So I'm going to show you guys that. Okay, multiply, then simplify if possible. Okay, so we have 2 root 3 times 5 root 6. So let's multiply the normal numbers. 2 times 5 is 10. And then 3 times 6 will be root 18. Now we're looking for 1, 4, 9, 16, 25, 36, 49, 64. Okay, so we're looking for any factors of 18 that are these numbers. So we can do 10 times, we can break down root 18 into root 9 times root 2. Well, what's root 9? It's 3. So we get 10 times 3, which is 30 root 2. Okay, next one. 2 times 3 is 6, and 5 times 10 is 50. So we get 6 root 50. But 50 can break down and simplify a little bit more. Okay, we can break 50 down into root 25 times root 2. Okay, so root 25, we get 5. So 6 times 5 is 30 root 2. And that's the simplest form. Okay, so let's multiply C. 9 times 4 is 36. And then 14 times 2 is 28. So we can break down 28 into root 4, root 7. Okay, and 4 is just 2, so 36 times 2 is 72, and then we leave the root 7. Okay, so 3 times 5 is 15. And then 6 times 6, well, we can either write this as root 36, but root 36 actually cancels as we learned before. So what's 15 times 6? 90. Okay, so now let's tackle division. And again, down the side of my paper, I'm going to go 1, 4, 9, 16, 5 squared, 6 squared, 7 squared, 8 squared, 64. Okay, so 48, what can we break down 48 into? Well, we can break it down into, rewind. We can't break it down into any of these numbers here, but what we could also try to break it down into is the denominator so that we can cancel out the denominator. So we can rewrite 48 as root 8 root 6, keep the denominator as is, and then the denominator cancels out. So we get root 8. Okay, 225, we can break that over root 3. Well, does 225 divide by 3? Yes, it's 75 times 3. And then that's going to be over root 3. So those root 3's cancel out. So we're left with root 75. However, if you notice, root 75 can break down into one of these perfect squares. So we have root 25 times root 3. This simplifies to 5 root 3. Okay, so this time we have 6 root 5. 5 is a prime number. It only breaks down into 1 times 5. So we're kind of stuck with that there. But we can look at the denominator. Can this denominator break down into 5? Well, yes, it can. So leave the 6 root 5 on the top, and we're going to break down the denominator into root 32 times root 5. Okay, because 32 times 5 is 160. So here we're going to get 6 over root 32. Now, root 32 can be broken down into a perfect square. So we get 6 over root 16 root 2. The 16 cancels to an 8. I'm going to put this beside each other. 8 root 2. And 6 over 8 can both be divided by 2. So we get 3 over 4 root 2. All right, so next one. So the normal numbers, negative 10 divided by 2, we can divide that. So that cancels to negative 5. Now 384 divided by, root 384 divided by root 8. Well, root 384 can be divided by root 8. We have 48, root 48, root 8. And then this would be left over the root 8, and we can cancel those. So now we're just dealing with negative 5 root 48. Now, does the 48 divide by any of these numbers? Yes, it does. It divides by 16. So root 5 times, negative 5 times root 16, which cancels to 4, times 3. Because 16 times 3 would equal 48. So I get negative 20 root 3. Okay, more practice. Simplify by first simplifying the radical and then finding a common factor. So I'm going to call the radical, nothing can be simplified here. So I'm going to pull out a 7. So we can factor out a 7 at the top. From 21, 3 is left, and from 14, 2 is left. Well, 2 root 6. So we can cancel those out. And we get 3 minus 2 root 6. Okay, what can we pull out of 10 and then 1 root 60? Well, let's see what we can pull out of root 60. Okay, so we can pull out 60 divides by 4. So root 4 root 15. So we have 10 plus 2 root 15 divided by 2. Now we want to get rid of the 2, so let's factor 2 out of the top. And we get 5 plus root 15 over 2. We can simply cancel those 2's out. And we're left with 5 plus root 15. Okay, and the last one. What can we pull out of root 125? Well, we can break that down. So root negative 15 plus 2 times root 25 times root 5, and that will be a 5. Leave the 5 as the denominator. So I get negative 15 plus 2 times 5 is 10, root 5, all over 5. So let's go ahead and factor out a 5 out of the numerator. I get negative 3 plus 2 root 5, all over 5. We can cancel those out. We're left with negative 3 plus 2 root 5. Adding and subtracting radicals. So adding and subtracting radicals work similar to adding and subtracting polynomials. Okay, we can only add or subtract the like for example, like the like radicals. Okay, numbers where the value are under like the radical sign are the same. Okay, so we could add like root 5 and then like 2 root 5 since the number under the radical sign is the same. So number 1, what we do is we simplify the radicals by pulling out perfect squares and rewriting as mixed radicals. Okay, so pull out everything, simplify as much as you can, and then what we can do from there is add or subtract the whole numbers in front of the radical while leaving the radicand the same. So this works the same, like for example, if you had like 2x plus 3x, you would add or subtract the 2 and the 3, and you would leave the x as it is. Okay, so leave the radicand as the same as well. So simplify. What we want to do first is we want to break these down as simple as possible. So again, we're looking for like that 1, 4, 9, 16, 25, 36, and so on. Okay, so we're looking for these numbers. Okay, what can we break down 24 into? Okay, so we can go, 24 breaks down into root 4 root 6, 54 breaks down into root 9 root 6, and 150 breaks down into root 25 root 6. Okay, root 4 is just 2, so we get 2 root 6. Root 9 is just 3, so we get negative 3 root 6. And 25 is just 5, so we get plus 5 root 6. So what we do here is we have root 6, and root 6. So that's kind of like our quote-unquote like term. And we do 6 minus 3 and then plus 5, so we get 4. Oh, sorry, this is a 2. Sorry, that's a 2. So 2 minus 3, which is negative 1, plus 5, that's where we get the 4 from. So our answer is 4 root 6. Okay, now let's break these ones down. So root 48, we carry down the 3, and we break down root 48 into root 16 and root 3. Minus root 8 breaks down into 4 and 2. So copy the negative 4 and then root 4 root 2. Okay, plus 4. Root 27 will break down into root 9 root 3. And then minus 2. Root 72 breaks down to root 36 root 2. In this line, 16 goes to a 4, 4 goes to a 2, root 9 goes to a 3, root 36 goes to a 6. So let's just simplify. 3 times 4 is 12, and keep the root 3. 4 times 2 is 8, and keep the 2. 4 times 3 is 12, and keep the 3. 2 times 6 is 12, keep the 2. Okay, so here are the like terms. We have 12 root 3 and 12 root 3, which gives us 24 root 3. Okay, and then we have negative 8 root 2 minus 12 root 2, so we get negative 20 root 2. Okay, the next topic about radicals, multiplying radicals and binomials. So, if we have a monomial and a binomial, we apply distributive property. We collect like terms, and then we fully simplify. Okay, and a binomial times a binomial, we FOIL like usual or do like what I call the rainbow method. Okay, so expand and simplify the following. We're going to multiply 2 root 2 by root 10. Okay, so the number in front of root 10 is 1, so we get 2 root 20. Okay, now let's multiply 2 root 2 by 3 root 14. We get minus 6 root 28. Okay, now let's break down. 20 can break down into root 4 times root 5, and 28 can break down into root 4 times root 7. So the root 4's cancel to 2's. 2 times 2 is 4, so we get 4 root 5 minus 12 root 7. Okay, that's a monomial by a binomial. Now, let's multiply 2 root 3 by root 3. So 2 root 9. 2 root 3 times negative 4 root 5. Negative 8 root 15. Root 5 times root 3 is root 15. And root 5 times negative 4 root 5, negative 4 root 25. I'm going to cancel all the ones that we can. So root 9 already cancels and root 25 already cancels. So let's go ahead and add these or simplify this. 2 times 3 is 6. Okay, we can simplify. We can add these in this step. Negative 8 plus 1, so negative 7 root 15. And then negative 4 times 5 is negative 20. Okay, 6 minus 20 is negative 14, minus 7 root 15. And we'll stop there. Because this one doesn't have a root sign on it, we don't have to keep breaking this down because we won't ever be able to add them again. Okay, I'm going to teach you guys what a conjugate is, and this comes up again in calculus, so this is really important next year. A conjugate is formed by changing the sign between two terms of a binomial. So the conjugate of x plus y is just x minus y. I'm going to show you why this is important when we have root signs or radicals. Okay, so let's go ahead and expand and simplify. So if we take a look at this, this is actually like a difference of squares, factored, right? So 2 times 2 is 4, 2 times negative root 3, negative 2 root 3. Root 3 times 2 is plus 2 root 3. Root 3 times root 3 is negative root 9. Okay, if we take a look in here, this is why this is so important, and this will come up in calculus again. Negative 2 root 3 and positive 2 root 3 go away. We are left with 4, and then minus root 9 is just 3. We're left with just a number. So the purpose of a conjugate is to get rid of those two middle numbers by one being positive, one being negative, and then they can cancel out. All right, last talk about radicals. Fractions with radicals in the denominator. Fractions can contain a radical in the denominator are not yet reduced to simplest terms. To fully simplify a fraction with a radical in the denominator, we must rationalize the denominator. Okay, so this will come back again in calculus. To rationalize the denominator is to get the root out of the denominator. Okay, so how to rationalize the denominator? Number one, a monomial in the denominator. We multiply the numerator in the denominator by the radical in the denominator. Okay, so essentially we're multiplying by 1 because it's going to be, like for example, with 9a, we would multiply it by root 6 over root 6. And the reason why this works is because the numerator would now be 5 root 6. The denominator would become root 36, which cancels out. So we get 5 root 6 over 6. You're allowed to still have something in the denominator, but it just can't be a root sign. Okay, let's practice that one more time. 2 root 5 and 6 root 10. Well, just multiply by the radical in the denominator, root 10 over root 10. This gives us the root 10 times root 10, root 100, which cancels out to 10. So we would get 2 root 50 over 6 root 100. Well, root 100 goes down to 10. So we get 2 root 50 over 60. Okay, and from this point, we can just keep simplifying. 2 over 60 would be root 50 over 30. And then root 50 can break down into root 10, root 5. Oh, no. We would need something rooted because 30 is not under a root sign. So let's go root 25, root 2. Root 25 breaks down into 5. We'll have 5 root 2 over 30. Those will cancel. 30 goes down to 6. We get root 2 over 6. Okay, now number 2, a binomial in the denominator, we would multiply by the conjugate. Okay, so this is what really comes back in calc. So if we have a binomial 2 root 5 minus root 3, we would multiply both the numerator and the denominator by 2 root 5 plus root 3. Okay, we can keep the numerator factored, it doesn't really matter, or you could distribute the 4 in. Okay, but the denominator, this is where it becomes important. 2 times 2 is 4, root 5 times root 5 is root 25. We know that cancels, so we're good. Plus 2 root 15 minus 2 root 15, and then minus root 9, which again cancels to 3. Okay, these two middle numbers are plus minus, they're opposite, so they go away. So we get 4, 2 root 5 plus root 3 over, we get 20 minus 3. 20 minus 3 is 17. So we can write this. If you want to just distribute this, that's fine. 8 root 5 plus root 3 plus 4 root 3 over 17. Okay, so you notice how the denominator no longer has a root sign in it. Okay, last one. 3 root 7 minus 2 root 3. 3 root 7 minus 2 root 3. Let's just, let's expand everything from the beginning. Okay, so we'll bracket that. So we have 2 times 3 is 6, root 7 times root 7. I'm actually going to skip this step. It's just 7. Okay, 2 times negative 2, 7 times 3. Then we have negative root 3, so we get negative 3 root 21. And then negative 1 times negative 2, I get plus 2. And then that's root 9. And that simplifies to 3. Actually, I'm going to skip that step as well. Now let's take a look at the denominator. 3 times 3 is 9. Root 7 times root 7 is 7. Okay, the middle two terms cancel, but we can write them out. So I get negative 6 root 21 plus 6 root 21. Those go away. Now we're left with 2 times negative 2, so negative 4 times root 3 is just 3. So if we actually simplify all of this, we get 42 minus 4 root 21 minus 9 root 7 plus 6. So I'll simplify these two. Negative 4 minus 3 is negative 7 root 21. There we go, plus 6. All over 63 minus 12. Okay, so 42 plus 6, we get 48 minus 7 root 21. All over, and then we get 63 minus 12, and we get 51.